I hope everyone had a great lunch and is still hungry for some information. So my talk is about training in AR VR at Siemens. The question is, what's up with virtual training at Siemens? So we've seen lots of examples even at that conference. Bosch is doing training, everyone is doing training, Deutsche Bahn is doing training, so we have lots of training applications there. So the reason for Siemens to go into virtual reality training is there's a huge engineering portfolio at Siemens. So engines, converters, IPCs, you can name it. And the idea for this one initially was to train for a bearing change in one of the torque engines Siemens is producing. And so we designed a training for that, but then we thought we shouldn't stop there because doing a one-off training, custom design for this use case might not be enough because Siemens has so many engineering requirements and use cases that need to be trained for. So what we were trying to do is to make it extensible for other scenarios. So to give you an overview why virtual training, the first reason is that cost, time, and logistics. So if you take an engine, for example, there might be 10 or 100 pieces of it produced. They might cost 100,000 between 1 million. If you need to train for it, it might not be available. It might still be manufacturing. It might not even exist yet because it's still in the design stage. Trainees need to travel around the world to get into one location where the engine is. So from Singapore, from United States, from everywhere. That costs a lot of money. The teaching methods might be a bit problematic. For example, classroom trainings for engineering. You learn in a classroom how to repair an engine. Scalability, if you do hands-on training, you have 20 people in a single room. It might not be certain that all 20 people can repair the engine in that session. The training cannot be repeated that easily. Most often it's not even recorded, so people can view it again. Then you have language barriers. As said before, people are traveling from all around the world into one location, for example, in Germany, and the common language is English. There's possibility of misunderstandings. The documentation might be lacking. And what we found out is that there might be also a lack in KPIs and analysis. So how good is the quality of the training? How good is the teaching method? Do the guys who have been trained for repairing the engine, did they do it properly when they repair the engine? So this is what we came up with for a training scenario. This is the engine, and this is a very basic demonstrator. So we tried to figure out a couple of things. So here, there's just a step-by-step procedure of removing 3 screws in any order, for example. And if you get the step completed, if you get it right, then you get a feedback for that. Your points are collected and then later evaluated. So basically, you're also doing a test in some sort. And you're just doing the training as you would in the real world. So in this case, you use a controller, a VR controller, but we're also working on using tools, so virtual tools, like a virtual screwdriver, virtual power drill, virtual cranes, virtual pneumatic pumps, and stuff like that. So the idea is that a trainee is doing it as realistic as possible. So not on paper, not in front of a desktop PC, not in a classroom, but he just does the training. If something is not real enough, we help ourselves with videos, photographs, audio files. Yeah, and you see here, there's, for example, a custom box. It has a real representation, so it's been built, containing spare parts needed for repairing the engine, and we digitalized that, basically created a 3D model, made it interactive, and that gives you the idea of the training. since it needs to be extensible, our focus was not on the training itself, but more on the authoring part. So we've heard yesterday, for example, authoring training at Bosch, for example. It's a similar principle. The thing we focus on is authoring directly in VR. So we don't do it in the desktop. We don't do it with a 2D editor. We do it directly in VR. So the idea is that an author performs the training or the teaching just as he would do it in the real world. Then the other aspect is recording that training, replaying it back interactively so the trainee can use it. And the next step is then doing it co-located. So both authoring and training in a multiplayer environment, for example. Yeah, that's it basically. I jumped one screen. And the last thing is also that if we do a training in VR, and we have recorded that in a document, in a structured document, we can also publish it to VR, AR, tablet, desktop, to anything we like. We could even print out a 2D, a paper sheet with the step-by-step instructions, for example. So where do you begin when you want to design something like this? The first thing that probably everyone runs into is where to get the content. So our problems, we need CAD models, we need models of third-party tools, for example, like this Enerpac hydraulic pump. We need models of custom tools that, for example, are built. You need custom spare parts to repair an engine specifically. Like you need to create new elements to attach to the engine to be able to separate it into two pieces, for example, so you can access what you actually want to repair. Then you need images, video, audio files, technical documentation. You need that. You need expert knowledge. So what we found is that we don't even have a correct content management process for that. We do have CAD models. We do have models available of third-party tools. We have our custom tools. But sometimes our custom tools they're only blueprints. There might not even be a blueprint because it was done on the fly. It was created in the workshop directly, so we have to 3D scan all of it. Images need to be taken of the real thing, and as said before, it might be complicated to access one because it's already delivered or there's nothing, it's not even a manufacturing state. Yeah. And one thing we ran into, for example, if we need that Enerpac pump, do we have the rights to use that model, or do we have to create a generic pump which doesn't resemble what the guys in the workshop are actually using? And there's the question, maybe we can think of a new business model, like buy the real pump and get a digital copy of it. So the other problem we ran into, that CAD models are pretty dumb, and 3D scans are even dumber. So we need smart models. We need tools like that. We need a crane, which is usable. We need simulations like chains. We need cables. We need wiring. We need even cloth simulation. We need to find a way to make that smart. We need to, because if we have the geometry, that isn't enough. We need to, since our goal is to train like in the real world, we need to find a way to process the geometry so it's actually interactive. And we're still on the way of figuring that out. So we are still lots of manual work. We need to look at it from use case to use case. We need to do custom development for that. But our solution at the moment is to use a library, because the author doesn't want to deal with any of this. So we don't want any development work in the authoring environment. The author just wants to use a drill, a crane, and spare parts to repair the engine. He doesn't want to program any of that. So our approach is to use a library of content which is generated by demand. So if a new training needs to be designed, for example, the first thing we did is an torque engine. The next thing is an industrial PC which needs to be repaired. Then we need to have a feedback cycle of the author telling us, oh, I need I need a screwdriver, I need a drill, I need wiring. And that's need to be feedback to a group of 3D artists, developers, CAD model designers who get us that. And then it's put into a library so it can be reused for the next training that's similar. And then there's also custom content, which is just needed for the specific training. But it's the same principle, it just doesn't end up in the library. Or it might be if you see that there's a potential use case for that. That's it. So the author needs to be able to request a change, new content or features, so you need to have a process for that. Now that we have an idea how to solve that content problem, which is actually the biggest one, it's about getting real. So this is the use cases you're training for, basically. Heavy engineering, heavy tools, people who might not even be digital natives. So yesterday the talk about training 4.0 by Dr. Wild, incidentally, was about, showed that there's a significant difference between people already being digital natives about accepting VR than people who have not even using the internet and they're supposed to use VR. So we are dealing with users who have less experience with that, and then we are suddenly forcing them to use a VR application to learn engineering. So the user experience aspect is that we have to take in mind 3 user types: the author, who doesn't necessarily be the trainer, and the trainee. Author and trainer can be the same, but it doesn't have to be. And they have to deal with the application itself, so just the VR application. It's like Word or PowerPoint, a tool they use every day to create trainings. Then we have to keep in mind the user experience of the virtual tools we create, because we are dealing with a VR controller, like from the HTC Vive, for example, or hand tracking, and we need to map that on a screwdriver, which isn't really that natural and intuitive to understand. And also equipment, like if you have a crane, there's a question how to use it. We've tried actually to recreate a physical interface, like a crane has a remote control and we need to access it with using the VR controller. Then we figured out that might not be the real thing, so we need to use a 2D UI for that with sliders and buttons. So that has its complications. And then we also have the aspect of the user experience of the training itself, which is designed by the application, or rather by the author using the application. So there's the problem of abstraction and learning in this. So in the application, you, for example, have different user experience patterns, like you have a teleportation. You can jump around, as you've seen in the video. We try to base everything on a grab and release pattern, like you just grab things, release them, and everything is recorded in background. You have UI navigation, which you need to get used to. You have physics, which might be not realistic at all, and that needs to be learned first. Then you have the tools and equipment. So as I said, you have a VR controller, and you're actually supposed to use a power drill. You have unique user interfaces for each tool. That requires to make an abstraction of the real world. And then you have the training document, which the author designs. So you have to do the didactics needs to be good, the teaching methods, the content quality. So that makes or breaks the training, actually. And now the question is, virtual training the solution? And actually, it's the question, what was the problem before? So what are we actually solving? When you look at the strengths and weaknesses of VR, the strengths are clearly exploration, simulation. You can play with time and space. You can learn spatial geometric problems. You can learn the step-by-step sequences, which we found out is actually that's actually the biggest feedback we got. Is people told us it's cool, it's great, and we can use it to learn the instruction step by step, basically. The weaknesses come from the hardware and from yeah, basically from the hardware. So if you have fine tooling, like you need to use a screwdriver on a screw, and you have bulky controllers, the precision is not that good. Photorealism is sometimes an option, a difficult problem. Sometimes we get feedback that it's too clean, it's too abstract. I need a workshop environment. Sometimes it's okay. Physics are a problem, as said. We need chains, we need cloths, we need cables and stuff. And then we have the problem of the lack of sensory input. People are supposed to repair an engine, and it contains parts that weigh 100 kilos or even more. And in VR, they're just able to grab it and throw it away. And the question is if that is even required. Do we really have to go at length and try to simulate that weight with whatever hardware, like robotic arms or gloves or electrocuting the arms of the people so they get an idea that it's heavy? The question is if we really need to do that, or if people can make the abstraction. And what we found is that there's a big difference between theory and practice, basically. So the current strength of VR is that you learn the theory. And the weaknesses go more into the direction that you need practice. You need to, if I show you a VR training of changing your wheels, for example, which at that time of the year will get a bit current, and then you have to do it yourself, you will have problems. So you have to train that on the real thing. It's also the same principle with airplane flight simulators. You train in a virtual environment, but you have to fly the real thing first. So there is a potential to bridge the gap between theory and practice, but that will take time. The hardware needs to catch up. We need to find some ways. As said before, do we need gloves, or can we maybe do it by software, like simulate in some way that a part is heavy and get the idea into the minds of the people that it's heavy and I need to pay attention to that. And the other question is virtual reality versus augmented reality, which is better for training? And it's just the basic differences. So in VR, we can interact with virtual objects, so we don't have to deal with transporting everything. We can reduce the costs, the logistics. We can use an infinite virtual environment. We have all the options available. We get all the information, so I can clearly tell if I remove the screw or not. I can simulate consequences, so I can blow everything up. And it's risk-free, so I don't die when I blow everything up. In AR, when I do training in AR, I have logistics, because I need to train on a real thing. My environment is limited to the workshop I'm training in, or the living room I'm training in. We need to track the objects, like if I remove a screw, I need to track that I actually removed the screw to get further. I have real consequences, so if I mess it up, I might die, even if I use AR-assisted training. There's still a risk. If I do it wrong, I die. And that's the basic difference. So VR, in my point of view, is very good for training, and AR is more in the maintenance perspective, because we have lots of examples in this conference as well, like remote assistance. That's what AR is good for. You're in front of the real object, you know what you're doing, and you need some assistance. Call an expert, and then he tells you if you're correct or not. There is crossover potential for using VR and AR at the same time, which is, for example, remote field maintenance. If I am in front of the real object, and I have the hardware for doing 3D tracking and getting my position and stuff like that, I can communicate with someone in a VR environment who sees all of that, who can do the things, maybe even assisted with simulation. He can try repairing it before you do, and then he can tell what happens if you do, and then he can do the thing for real. The other aspect, if you do have a perfect VR application, you invested millions of dollars into that, your trainings can still be extremely terrible. Because the authors need to have a good didactic concept. They need to know what they're doing. They need to know how to teach you something. And the authors, just from the job role, basically, they need to be experts in engineering, then in VR or AR, and in teaching. So you can have a good teacher, you can have a bad teacher. There are solutions and workarounds for that, because since we are then software-based, we can help the authors with wizards, with AI assistants maybe. We can also do in-app feedback. Like if you use the AWE app, you can give feedback for the talks, for example. There can be review cycles. Is the training good or is it bad? And so you can, since you digitalize the process, you can create better trainings with that. And that's the next point. You probably don't need VR. You might at first need digitalization. You might find that in your company, the current process is based on paper, PowerPoint, classroom trainings. You might have documents of bad quality. You might have unqualified trainers, or people who are qualified but can't express themselves in a good way. You might find that your trainings are not recorded, so they can't be repeated. You have no processes, no KPIs. So effective VR can be the driver for digitalization in this point, because if you have the app, you can add features that support your digitalization process. As said before, feedback, your documents are published across platforms. You can repeat everything. You can do offline trainings, online trainings. And the other point is, you might probably not need VR at all. If you take a look at this guy who's trying to train for repairing a computer, he's using his fingers with tiny screwdrivers. He needs to connect cables. He needs to understand how it all works. And at the current situation, he has to use a bulky controller. He has to use his finger tracking, which might lose tracking here. It's maybe not well implemented to use a screwdriver on a tiny screw. The simulation of cables might break down, and that might conflict with his training target. So if you use VR and AR for the wrong use cases, you undermine the potential of the entire technology. And if you have someone who trains with that application, he's probably going to tell you, that sucked, I'm not going to use it again. But you might still need VR if you use it to change maybe perspective. So this is still repairing wiring on an object which is complex and tiny, but you can use VR to get small and repair it. And then you understand the concept of what you have to do. And that's it. Any questions?
Thank you, Robert. Any questions? Over there.
Thanks for the presentation. Very enlightening. I was wondering, how do you foresee the creation of this platform? Because you are, I think you're pioneering it inside of Siemens, right? With Siemens employees developing the platform. Do you see it as an open ecosystem? Is it something that will be primarily invented within Siemens? Are you working together with startups?
Well, we do, maybe. But it's actually an open approach. So what I can tell is we use open source libraries, for example, but it's meant to be a service currently for Siemens customers. So it's internally developed. It's in the early stages, or maybe not. And yeah, we'll see actually about that.
Anyone else?
I wonder, did you ever really compare groups like using this VR application and doing it in real life? Like, yes, you were questioning if VR really is the good thing, but did you ever really compare it?
We are going to actually. So we are at about the stages to where we are able to compare it. In a talk yesterday was also mentioned that you can compare it the easiest with taking the exams they are taking at the end. So when you train for engineering, you usually do tests at the end, and the easiest thing is to test: is it better before than after using VR? But then there are also the other things, like if that's one of the problems. If you don't have KPIs before, you can't compare it. So you don't necessarily know if your training is bad or good at the moment. So you have to do that analysis before, and then you can compare it to the new approach, which might be a problem with some customers or some industries. Yeah, but we are going to do that. Yeah.
I hope your question has been answered.
Fully?
We've got room for one more.
Oh, no.
So I don't know who was first. Over here? No. Okay. So I guess he was first.
Yeah. My question is about so 3D graphic at all. I mean, computer graphic. It exists a long time. So now you're focused on virtual reality. So what about the previous experience in Siemens? So is there any experience of creating simulation but using the simple PCs? So because a lot of problems of solving that 3D CAD data is huge, but we knew it 10 years ago, so or more. So now you're like, and what stage you are? You're beginning from your starts from the beginning, or you use already previous experience of Siemens of creating simulations using 3D?
Oh yeah, sure. I mean, Siemens is big in simulations, like in NX, the software used for CAD modeling and stuff, and it's also used for simulations. The thing is that the training can be run on a laptop, on a gaming laptop. That's also one of the reasons why the idea is to use that, because it's cheap. The hardware is cheap. You can go to the next MediaMarkt and buy it, and that means also that simulation is more possible than 10 years before. And we're also working together with the guys. I mean, Siemens is a big company, so one deals with simulation, the other one deals with VR, the next deals with artificial intelligence and stuff. And we're all working together to get the most out of this training.